Have you ever wondered what's going on deep inside a massive ship? Well, today, we're heading into the engine room to uncover a system that's always working but almost never seen. We're talking about the incredible energy recycling steam system. It's basically the hidden powerhouse that keeps the whole operation flowing smoothly.
So here's how we're going to break this all down. First, we'll get a sense of the ship's hidden network of pipes. Then, we're going to follow a single drop of water as it turns into powerful steam. After that, we'll see what its crucial mission is, watch it complete the full cycle, and finally, we'll zoom out to see how this amazing system fits into the bigger picture of modern shipping.
All right, first things first. To really get why this steam system is so cool, you have to appreciate the world it lives in. A modern ship, it isn't just a big metal box with an engine. It's much more like a floating industrial city.
And wow, this mind map really gives you a sense of that complexity, doesn't it? Just look at all these different systems for fuel, oil, water, air. It's a huge interconnected web. Today, we're just focusing on one of those threads, but trust me, it's one of the most clever ones, the steam system.
So to make sense of this, this maze of pipes, we're going to simplify things a lot. We're going to follow the entire journey of our hero for this explainer, a single, humble droplet of water.
Okay, so our droplets journey kicks off right here, inside a feed water tank, and it's about to go through a pretty wild transformation, powered by one of the strongest and most overlooked energy sources on the entire ship.
Now, the heart of any ship is its main engine. It's an absolute beast that generates enormous power, but it also creates a ton of waste heat. I mean, if you look at the diagram, you can see the exhaust boiler. This is where hot gas, we're talking over 240 degrees Celsius, would normally just escape out into the atmosphere. But on a modern ship, that energy is just too valuable to waste.
And this, right here, this is where the magic happens. This component is called an economizer. You can think of it like a giant radiator that sits right in the path of the engine's scorching hot exhaust. The design specifications for this are critical. It's built with special materials just to grab all that heat that would otherwise, poof, just disappear. It uses that captured energy to boil the water running through it. This is energy recycling at its absolute best.
And boom, just like that, our little water droplet isn't water anymore. It has soaked up all that waste energy and has been transformed into high-pressure, superheated steam. It's absolutely packed with thermal energy, and now it's ready to get to work.
So we've got all this powerful, superheated steam. What's it actually for? Well, it has a really critical mission, one that's totally vital for keeping the ship's main engine running smoothly.
You see, most of these huge ships run on a really fixed sludgy fuel called heavy fuel oil, or HFO. And at normal temperatures, like you see on the left, it's basically tar. You can't pump it, you can't filter it, and you certainly can't inject it into an engine. For it to be useful at all, it has to be heated up until it flows easily, and that's exactly where our steam comes in.
And the way it all works inside these massive fuel tanks is actually beautiful in its simplicity. Let's walk through it. First, the steam enters a special heating circuit. Then, a valve controls the flow to make sure the temperature is just right. Inside the tank, a specially designed coil transfers the steam's heat directly to the fuel. And finally, this really clever device called a steam trap releases the water only after the heat has been transferred.
And check this out. This diagram gives us a great close-up view. You can see the hot steam entering and flowing through that heating coil, which is submerged right there in the fuel oil. As it travels along, it radiates its heat out, warming up the fuel. And by giving away all its heat, our steam starts to cool down and condense back into water.
So, mission accomplished, right? The fuel is hot, it's flowing, the engine is happy. But for our little water droplet, the journey is only halfway done. It's time to head back home.
Because it gave up all its heat, our hero has transformed again. It's not steam anymore, it's hot water, or what's technically called condensate. Its job is done, but this water is way too valuable to just get thrown away.
So if you follow the lines on this diagram, you can actually trace its path. You can see how all the condensate from all over the ship is collected and then pumped back to a collection tank, which is called a hot well. And right from that tank, it's ready to be sent straight back to the exhaust spoiler to start the entire cycle all over again.
It's a perfect closed loop. I mean, think about it. Waste energy is captured, it's used for a critical job, and then the water is returned right back to the start with almost nothing lost. It's exactly like the slide says, nothing is wasted. This principle is really the foundation of modern marine engineering.
Okay, so now let's zoom out.
This elegant, super efficient system doesn't just exist in a bubble. It's part of a much, much larger world of operations. And that world is governed by some very strict international rules.
You know, a system like this doesn't exist just to be efficient. Every single system on a ship, especially the ones that handle fuel and oil, has to operate under a very strict set of international regulations that are all designed to protect the oceans. And the most important one is called the MARPOL Convention.
MARPOL is basically this giant rulebook for the oceans, and it's broken up into different sections, or annexes, that deal with different kinds of pollution. For example, Annex I, over on the left, has really strict rules about oil pollution. And Annex V, on the right, deals with garbage. It completely bans dumping any plastics at sea. And these are just two examples from a huge, comprehensive set of regulations.
And this is what really brings it all together. That clever steam system we've been following isn't just about saving fuel. It's a critical piece of a much larger puzzle. Meeting all these operational and environmental requirements is exactly how the global shipping industry works to coexist with our planet.
It really makes you think, doesn't it? Our whole world is powered by these invisible, interconnected systems. From the power grid that lights your home to the complex logistics that stock your local grocery store, they all run on these brilliant principles of efficiency, hiding incredible complexity just beneath the surface. What other ones can you think of that are working all around you right now?